Today we're going to talk about 12.2 electrical circuits and components on page 407. Okay, the first thing that we're going to talk about is resistivity. So if you have a resistance, the resistance is equal to resistivity and there. So it's the length divided by the cross section right there. So length divided by the cross section times the resistivity. Okay, so if you look at the resistance on the table of page 407, table 12.1, it gives you the resistance for a 1 foot long wire made of having a diameter of 1 mil. So if you look at it, there are some high ones and there's some low ones. So what do you actually want to use when you're trying to build send current through something on a commercial scale? You want something that's going to be small, right? So if you look at the smallest one is going to be silver, 9.8. Well, why don't we have any silver wire then? Because silver is more expensive, right? So that's why we have the next best thing, which is copper. Copper is 10.37, and we're going to use that's what we mainly use for wire. Okay. Now we talk about Ohm's law. Ohm's law is the resistance is equal to the voltage. Well, actually, current is equal to V divided by R. And this is you can also write this as V is equal to IR, where current is equal to the voltage divided by the resistance. Resistance is in ohms, so R would be in ohms. AR would be current would be in amperes, and voltage would be in volts. Right? Okay. So that's how we do that. If you look at example 12.2, it says the electric resistance of a light bulb is 145 ohms. Determine the value of the current flowing through the lamp when it's connected to 120 volts. So I would be equal to 120 volts divided by 145 ohms. If you do that, you're going to get 0.83, and it's measured in amps. Okay? All right, that's how it goes. And then we talk about the wire gauge. Wire gauge is something that if you look at you can read the table if you want. Then we talk about electrical power. Electrical power is equal to V times I. So it is the voltage times the current. So this can be also written as what? Since voltage is IR, this would be IR times I. So it's going to be I squared R, right? Which also, since V over R is I times V, so it's also equal to V squared over R. You'll see this in different forms. So this is 1, this is 2, and this is 3. There are 3 different ways to write that same equation when you want to calculate the power. Okay? And so power is used where? The most, where you usually see it is in your electric bill, right? In electric bill, you're going to be charged by kilowatt hours. How many kilowatts have you used per hour, right? And times the hour, not the amount of hours, right? So if you go to page 410, there's example 12.3. Assuming that your electric power company is charging you 10 cents for each kilowatt hour usage, so you're paying 10 cents for every kilowatt hour, right? Estimate the cost of leaving a 100-watt light bulb on from 6 p.m. to 11 p.m. 6 p.m. to 11 p.m. So that's what? 5 hours for 30 nights. So 5 hours. So you have 100 watts times 5 hours, and you're doing this for 30 days, right? So each day you're doing that, and the times 30, right? So this is going to be equal to what? We have, what, 1, 5, 1, 2, 3, watt hours, which is the same as kilowatt hours, right? So you're looking at 15 kilowatt hours, so 15 kilowatt hours, multiply that, these cancel out, you're going to get $1.50. Oh, $7.50. Okay, what am I missing here? Oh, it's 30 nights, not 10. Oh, 30 nights. 500, got that, times the 30, times 5 hours. Oh, 5 hours, oh, we got that. What am I missing? Oh, 5 light bulbs. There are 5 light bulbs. Okay. So 5 light bulbs, that'd be a 7 there, that'd be a 7 there. So you're going to have a 7 there, $7.50. Okay? All right. So on page 412, we're going to talk about series of circuits. So series circuits is when you have a battery or a voltage source. So I have a battery or a voltage source which is like this, and I have 1, 2, let's just say we have 2 resistors here, okay? So let's say that, so let's go example 12.4. Example 12.4. Okay, first of all, let's go to page 412 and equation number 12.5. When you are in series, and if I have, this is resistance is R1, this resistance is R2, the total resistance is R1 plus R2. If I had another one, I would just add that and keep on adding them, okay? That's if you are in series. When you are in series, you get to do it this way. Pretty simple. Okay, so let's see example 12.4. Let's do example 12.4. So in example 12.4, I have 3 light bulbs. So actually I'm going to have another one here. I'm going to have R3. Okay. Determine the total resistance and the current flowing in the current on the circuit shown as before. So I have 9 volts. So I have 9 volts. And I have 3, 7, and 19. 3, 7, and is it 9 or 19? 9, right? 9. 9 ohms, and ohms. Okay? So the total resistance is going to be R1 plus R2 plus R3. So I'm going to have 3 plus 7 plus 9 is 19 ohms, and I have a 9-volt source here. So the total current, you remember, was voltage divided by R. So my voltage was 9 divided by 19. And this is how many amps I'm going to get. Okay. And what am I trying to find? I'm determining the current flow, total resistance and the current flow. So there we go. We're all done. Okay. So, this is the current flow. So the voltage drop across each of these, if you do this, so the voltage drop across R1, if I call that V1, is nothing more than the current going through that times the resistance. So this is going to be 27 over 19. 3 times 9 is 27 over 19. So this is the voltage drop across here. The voltage drop across here is going to be what? The voltage drop across the second one is going to be 7 times 9, which is 63 over 19, not amps, volts. Right? The voltage drop across the third one is 9 times 9 is 81 over 19, and that's how many volts it is. Well, guess what? If you add these all together, what do you get? You get 27 plus that is 90. 90 plus that is what? 171. So 171 over 19. The total voltage drop, right, is going to be equal to what? What is that? That is 9, right? But it should be, right? So you have 9 volts. Some of it is used over here. Some of it uses over here. And some of it is used over here, right? But when you add them together, you get the same voltage drop. So total voltage drop across each of these resistors, when you add them together, should be the same as this one. Okay? So because of this, now I can go ahead and ask you questions like, what is the power? How much power did I use in R1, right? So how would I do that? The power that I use here is power is equal to V times I, where I was what? I was this, so 9 over 19, right? This is the I times the V is right here, 27 over 19. And whatever you get there is going to be how many watts, right? Okay, right? And you can do that. You can do that. So you can actually calculate the power consumed on each separate component. Okay? All right, we'll stop right here today.